Welcome to The Explainer. Today, we're grabbing our magnifying glasses and putting on our detective hats because we're diving deep into some of the most complex mysteries hidden inside the human brain. So, how do you solve a mystery that you can't see with your own eyes? Well, you look for clues. We're talking about subtle patterns on brain scans that act like fingerprints, each one uniquely identifying a different, complex neurological disease. Okay, let's jump right into our first case file. All right, so our first case opens with these mysterious spots showing up in the brain's white matter. Now, the number one suspect is usually multiple sclerosis, or MS. But here's the challenge. A lot of different conditions can create spots that look kind of similar. So our job, as detectives, is to find the specific signature, those telltale signs that point directly to MS and rule out the imposters. To really nail the diagnosis of MS, neurological detectives have a classic set of clues they look for. First, the pattern. The lesions tend to be perivascular, which means they kind of hug the blood vessels, especially near the brain's fluid-filled ventricles and the cortex. Then there's the shape. They're often ovoid, like little eggs, or they form these very distinctive Dawson's fingers that point straight out from the ventricles. And here is where location becomes everything. I mean, check this out. If those lesions touch this one very specific area called the collo-septal interface, that's right where the two halves of the brain meet, well, that is a 98% certain clue for MS. That's not just a hint, that is an incredibly reliable piece of evidence. Okay, now we've hit a critical fork in the road for our detectives. Is this spot an MS plaque or something much more sinister, like a brain tumor? Well, we can actually tell them apart just by looking at how they light up with contrast dye. Think of it like this. A tumor or an abscess, they often form a complete solid ring. It's like they're building a fortress to wall themselves off. But an active MS lesion, it usually enhances in this incomplete horseshoe shape. It's not a wall. It's more like the leading edge of a wave of inflammation. That simple difference is an incredibly powerful diagnostic tool. But of course, MS has other imposters, like a condition called CADASIL. It's the most common type of hereditary stroke disorder, and you can see how we tell them apart. While MS lesions hang out near the vessels, CADASIL lesions prefer the deep white matter. But the real giveaway for CADASIL is what it doesn't touch. See, the damage almost always spares these tiny little nerve fibers right under the cortex, called the subcortical U fibers. And that's huge, because MS often hits those exact fibers. Okay, now that we've seen how location and pattern can crack the case in white matter diseases, let's take those same detective skills and apply them to a whole new mystery, the Parkinson's puzzle. So you've got a patient with the classic tremor and slowness of Parkinson's disease, but something's not quite right. Some of the symptoms just don't fit. We might be dealing with a Parkinson's plus syndrome, a trickier mimic that forces us to look much, much closer at the brain. To solve this puzzle, neuroradiologists have some pretty amazing visual tricks up their sleeves. They call them mnemonics, and these aren't just quirky names. They are powerful diagnostic clues that describe very specific patterns of brain damage. Our first one points to a Parkinson plus syndrome called multiple system atrophy, or MSA. And this clue is just fantastic. See, in MSA, specific fibers in a part of the brainstem called the pons start to degenerate. When you look at an MRI, this tissue loss creates this bright signal pattern that looks, well, remarkably like a hot cross bun. If you see this sign, you have a very strong indicator for MSA. All right, now let's investigate another mimic, one called progressive supranuclear palsy, or PSP. This disease leaves behind a totally different but just as memorable calling card. To find it, we just have to look at the brain from a different angle, from the side, in what's called a sagittal view. And boom, there it is. With PSP, the midbrain shrinks down dramatically, but the pons right below it is relatively spared. And this creates this really distinct silhouette that looks just like a hummingbird. So think about it. MSA attacks the pons, but PSP goes for the midbrain. That's the critical distinction. Now, what's really wild is that if we look at the very same disease, PSP, from another angle, this time a cross-section or an axial view, we find another unforgettable sign. So, looking down on that shrunken midbrain, the specific pattern of tissue loss creates a shape that is uncannily similar to Mickey Mouse's head and ears. It's really incredible. Finding either the hummingbird or the Mickey Mouse sign is a super strong piece of evidence that points us directly to a diagnosis of PSP. So let's put it all together. We can crack the Parkinsonism code by looking at what's damaged and what's spared.
Classic Parkinson's disease, it usually spares the midbrain and pons. MSA, it attacks the pons, giving us that hot cross bun sign. And PSP, it targets the midbrain, giving us the hummingbird or Mickey Mouse sign. But it goes deeper. At the molecular level, there's another key difference. Both PD and MSA are synucleinopathies, caused by a buildup of the protein alpha-synuclein. But PSP is a tauopathy from a totally different protein called tau. So these really are fundamentally different diseases.
For our next case, we're shifting gears completely and diving into dementia. And to solve this mystery, we need a different kind of tool, an FDG PET scan. Now, unlike an MRI, which shows us the brain's structure, a PET scan shows us its function. It actually reveals how hard different parts of the brain are working by looking at their metabolism. And what we see are these strikingly different metabolic patterns. With Alzheimer's, there's a very distinct drop in activity in the back of the brain, in what are called the temporoparietal regions. The shape of this low energy zone, it looks just like a pair of headphones. It's so classic. But dementia from multiple small strokes, multi-infarct dementia, that's a whole different story. It just looks like scattered random patches of damage. It's chaotic, with no predictable pattern at all. All right, for our final case today, we have a real unexpected culprit. It shows up with movement problems that look a whole lot like Parkinson's, but it's not a degenerative disease at all. It's actually a metabolic disorder, and figuring that out can change absolutely everything for the patient. Our unexpected suspect is Wilson disease. It's a genetic condition, and it's treatable. The problem is the body can't get rid of excess copper, so it builds up to toxic levels, especially in the liver and the brain. And because we have treatments for it, getting the diagnosis right and getting it early can literally be life-changing. And you won't believe this, but Wilson disease creates one of the most famous, most memorable signs in all of neuroradiology. It's another one of these amazing visuals that points you straight to the diagnosis. And there it is, the face of the giant panda sign. You see this on a T2 MRI of the midbrain. The toxic copper deposits make one part, the tegmentum, appear bright, while other parts, the red nuclei and substantia nigra, stay dark. And the result is this picture that looks just like a panda's face. But that's not the only clue. If you look at a different type of scan, a T1 image, the basal ganglia can look unusually bright. And that's a very specific finding we don't see in those other movement disorders, making it another fantastic piece of evidence. So when you boil it all down, all of these cases show us the same thing. Neurological diagnoses through imaging is all about expert pattern recognition. From the horseshoe shape of an MS plaque to the hummingbird silhouette of PSP, every disease writes its own unique signature on the brain. The whole job is learning how to read that secret language. Understanding these signatures helps patients get the right diagnosis and the right treatment right now. And it really just leaves you wondering, as our imaging technology gets more and more powerful, what new patterns, what new secrets are we going to be able to unlock tomorrow?